what we have observed about this fascinating presentation is a change of paradigm. Actually, additive manufacturing is a sort of adding layers of material for production product, while in the past, manufacturing was subtracting material from mold-based production. So all this excitement about manufacturing we've seen in the past, much particularly on plastic prototype production. But the excitement now is for the industrially fit production and to large scale. You three talk about challenges. If I may focus and draw attention about the main challenges on aero industry, which would be for you the main challenge for large-scale production of additive manufacturing in the industry? May I kick off? Yeah.
Okay. In my opinion, it's difficult to point on only one challenge. I think that if I could choose, I would choose in price, cost, because 3D printing or additive manufacturing, metal additive manufacturing, is still very expensive, and lack of standards. I think that the standardization currently is not enough, and it is not covering the whole areas of printing technologies and all the processes that are required after printing in order to get a printed aerostructure.
Thank you. José Manuel,
Yeah,
how about you?
From my point of view, because I come from manufacturing engineering, it's not the point is not.
There is some echo. It's
Echo?
I cannot follow him.
For me, the most important point is to find the proper niche for every technology or for every application case. I mean, additive manufacturing has advantages in terms of lead time and also in weight savings, for instance. So finding in which cases we can exploit the weight savings, or in which cases we can exploit the lead time reduction, and in which conditions it is possible to relax inspections or post-treatment cost. Could mejor? Thank you. So in this case, perhaps it's better to find out the proper niche for every single application. I say I come from manufacturing engineering. My interest is not in R&D, but in R&D in the application really for flying parts, not so in the technology itself. So that's why I focus on this matter.
Do you share that point of view?
I share these views. Maybe what I would like to add is that at the end of the day, we have to make a business case out of all the, let's say, investment that we need to do in order to further develop the technology for an application. So when it comes to the business case, we have to think that in aeronautics it's common to find 20-year cycle time from the first technology development up to the point where there is a serial manufacturing of that particular technology. So maybe the challenge is to be patient. And once you have decided what is your technology development line, to maintain that course no matter what's happening around you. And that is a challenge itself.
I think in the past, the aeronautics industry has pioneered on all the breakthrough innovations for tackling societal challenges. Do you think that now, in the doors of the 4.0 industry and additive manufacturing, Aeronautics will also pioneer progress in the industrial production, or the cost and large scalability of the challenge will, let's say, hold it back from progress? maybe José Manuel.
Indeed, the successful implementation of additive manufacturing in some parts has opened the possibility to another application. So for me, it will be increased up to get the portion of the manufacturing space that probably fits to it. Probably we will find quite different applications for quite a stressed part or more stressed part, and for furniture in the cabin, or for metal parts just for bonding and so on. So I think it will be increased continuously up to the stabilization radio to share the space with machining and turning and welding and so on. So it's just the beginning, and because we found that it is possible, now we are searching for more use cases to make it possible, to make a business case, to leverage this success for next success. Okay?
From your body language, do you agree?
So, in my opinion, I think that in this case, as other cases, the aerostructures industry will go after the automotive industry because of the cost-effective technologies, and although the standards, the strict standards that are exist in this industry.
I share that view, and as I said before, maybe the space applications will go first, then secondary structure in aeronautics, finally primary structure, and we are talking about many years of development.
Thank you. We have listened to your success stories, but I'm sure that down the road you have also confronted many failures. And I would like if you could share with us how you overcome those failures to avoid our audience to make the same mistakes, and maybe...
I like to be in the technology development in my company. One of the things that I used to say to my colleagues is that there is no technology development if there is no failure, let's say, in front of you. I mean, failure is part of the technology development. What you have to do once you fail is to learn why, what are the reasons behind, learn from those reasons, and start studying the mechanism, the principles that you have not met. So, in my opinion, it has to be part of the equation. Of course, in the meantime, there is a good investment line behind.
Yeah, just a comment about this history of failures. In my facility, in the facility I work, there was a project, a small project, for vacuum systems for carbon fiber reformed plastics for the drilling. Everything was fine with polyamide devices, and we wanted to internalize in our own machine in plant. The change from SLS to FDM imposed a lot of restriction to the design that finally we decided to go on with the polyamide SLS technology, because it was completely impossible to get a good result. On the other hand, even for new materials, the setup, now I'm talking about selective laser melting. The key is to get a set of parameters to get what the supplier, the powder supplier says that it is possible to achieve with this powder. Well, to find out the correct parameter sets is a nightmare. If you can control the porosity, then the strength is not good enough. Then you have distortions during fabrication. So it's not that a printer that you put in your house and you just send something to print, because when the more complex the technology is, the setup procedure for manufacturing engineering is bigger. Something.
Long list of
A nightmare.
points to fail. So let's go to my case, or to my cases that I showed or shared with you. There were a lot of failures, a lot of non-successes, and the fact is that all of the parts that I shared with you and showed are demonstrators. None of them pass the airworthiness qualification and is going to fly. None of them. And this because of the immaturity of the technology, and because there are a lot of developments that should be taken in order to mature it. And if I look into the future and I listened to Miguel, to Mr. Sastilio, and I understood that his concept is to combine technologies. So this concept is the future, and the future is far away, but we will get there. We all must understand that the printer is an automatic machine, but it right now can't replace a human being.
Okay. You all talk about the future, and as we are quite running out of time, I would like to put some forward-looking question as a sort of summing up. So in the conference next year, which type of question do you think you will be answering, and which question you are already fed up about the skeptical opinions on the additive manufacturing industry? So, if possible, quite crisp and straight, how you will see next year conference the additive manufacturing responding to the challenge?
Well, for me, and I'm talking from my own point of view, from my department and my involvement in this technology, I think that for a potential supplier that now is asking for that, is it worth it to invest in this technology? Is it possible for me to become a supplier? So perhaps the question in 1 year is, perhaps I should invest last year, because if you consider that a machine lasts about 2 years or more than a year to be put in your facility, perhaps if you take the decision next year, it's a bit late. So perhaps the question is why I didn't make the decision last year. Perhaps why not? I hope.
Mr. Castillo?
I agree. The aerostructures industry is a traditional industry, and the things are not changing. For example, like electronics or avionics or all other systems that are based on computer systems. And I think that in the next year we will present ongoing developments that we are focused in them right now. I don't think that there will be any new in this area, because the area, the, the, the market of the printed aerostructures could be led by two leaders. One leader is the aircraft manufacturers, like you, and the other leader is the printer manufacturers that should support and develop the appropriate printer that could print a qualified aerostructure.
Okay.
Well, in the case of maybe in 1 year from now, I could be presenting more tooling with different, let's say, features, because in the tooling domain, I think that the limit right now is purely on the imagination of our engineers on how to integrate the parts. There are some metallurgical challenges for some materials, but it's going to be much easier for non-flyable part to introduce the technology than for the flyable parts.
Okay, thank you. And ladies and gentlemen, I would be asking you many questions. I think many questions are still open, but I'm afraid we ran out of time. So if there are some questions from the audience, I invite you to join the panel in the exhibition. But now I will finish with asking a big applause for our panel. Thank you very much for your insights. Thank you.